Let's look at the last example problem. This is a lead code problem. Remove covered intervals. We are given a list of intervals like the previous example problem, but instead of removing some intervals so that the remaining ones are not overlapping, here we are trying to find intervals that are covered by another interval in the list and then remove those. So after we are done removing all the intervals that are covered, we return the number of remaining intervals. So here are some sample inputs. So in this one, we have a 5, 7 is covered by 5, 9, should be deleted. And then we have a 3, 5, and 5, 9 remaining, so 2 remaining. In this one, 3, 5, 4, 7, neither is covered by the other. 4, 7, 5, 9, neither covered by the other. 3, 5, and 5, 9, neither covered by the other, so all 3 can remain. So we have 3. And this one, we have a 3, 9 covers both 3, 5, and 3, 7, so remaining should be 1. So next one actually is the same 3 interval, but just in different order. So a straightforward quadratic algorithm is trivial. So for every interval, we just going through all the other ones, find any interval that it covers and delete them. So this would work. But this is quadratic time. But we can solve this problem in linear time. So suggest you try that first before moving forward with the video. So in general, with this interval problem, we try sweeping. We try sort them at least based on the starting point, and then sweep from left to right and see whether we can make it work. I guess similarly, we could probably sort it on the right based on the ending point, and then going from right to left. I think that's symmetric. So let's say we remember one interval, and let's say we remember one interval, and then we'll process the second one, the next one. So what are the possible cases that we need to handle? First is they do not overlap. So the first one and second one do not overlap. Then neither need to be removed because neither one is covered by the other. And also it's safe to remove to forget the first one, because the first one can never cover anything coming later. So for example, here we have 3, 5, and 5, 7. They're not overlapping. Then we don't need to remember anything about 3, 5. So 3, 5 cannot possibly be covered by something coming later, because this all of the later will start at 5 or later, so they cannot possibly cover 3, 5. And also 3, 5 cannot possibly cover anything later because it ends before this one starts. So it must end before all the other ones start. So it cannot possibly cover anything. So we can forget that and then just remember this. And this one can remain. So that's an easy case. Another case is that the two intervals overlap, but neither cover the other. So this is an example of that. We have 3, 5, and 4, 7. They overlap, but neither cover the other. Now, for the same logic like the previous one, 3, 5 cannot cover anything comes later, because anything later cannot cover 3, 5, because anything later will start after after 3, so it's there's no chance to cover 3, 5. And also 3, 5 cannot cover anything later because anything that could be covered by 3, 5 would also be covered by 4, 7. Because I guess here, if we have an interval 4, 5 here, that's actually covered by 3, 5. However, because this thing ends before this thing, and anything later will start at least no earlier than 4, anything here that covered by 3, 5, anything come later that covered by 3, 5, for example, interval 4, 5 will also be covered by 4, 7 when 3, 5 overlap with 4, 7. Because when they overlap, that means this first one must start earlier, but end earlier. So if it also end later, it will cover this. So this one will end before after that. So anything covered here will also be covered here. So we can forget about the first one, but then we can keep track of the second one. So the last case is if one cover the other, that's the easy case. Then we simply keep track of the larger one because the covered one is already removed, and anything it could cover will be also covered by the bigger one. So I guess in this case, if we have 3, 5, and 3, 7, we know 3, 5 is covered. We just need to remember 3, 7. And then when we see 3, 9, we can forget about 3, 7. We know it's covered, but we can forget it. So if we keep track of the intervals, the same logic can work here. We have 3, 9, and the next one is 3, 7. It's covered. So we remove that, and we remember the ones that cover it. So this would work. But can we do it similar to the previous question where we only keep track of the rightmost point instead of keeping track of the interval where we have both left point and right point? And the answer is yes. So that's what my code implement. So I first sort the intervals, and then I remember this max right. So this is the maximum right point I'm trying to remember. And this answer is the number of interval at the end. So it starts at all interval kept. When we find the covered one, we will subtract 1 from this answer. So we look at each interval. If the interval's right point is greater than max right, so then that's definitely not covered. So then we will keep remember this value instead of the old max right. Otherwise, if the right point is less than max right, so max right represent the ending point of some interval that come earlier. Because we sort by starting point, if x1 is less than max right, x0 is guaranteed to be greater than the interval who have max right. So then that means this new interval is covered. So I guess it should be this case. If we're looking at this, we remember 9. Whenever we see a 7, we know it has to be covered because these intervals must start after no earlier than the previous interval start. And if the ending point is also less than this, then it must be covered. So we just subtract the answer. So this is so this is a part of the code, but without the comparator. So the same question as the previous one. Which one is correct for the for this question? So again, I want you to think about it and figure out the answer. And another thing to think about is what if instead of just remembering the right point, we actually also remember the left point and we do this. In that case, which of the comparator would be correct? Okay, so greedy is a topic in some sense difficult to teach because different kind of problems will have a different. You will use different idea to order things, and you will use so some of the most difficult competitive programming problems are greedy because it doesn't rely on. It's not like you see it and you know it. You can apply this algorithm. Those are not challenging enough at the top level because everyone knows all the basic algorithm that can be applied. So oftentimes the greedy some of the insight are difficult to capture. So the way to learn greedy is to do lots of problems. So here are some of the problems from LeetCode that I look at and think they are interesting. So I also look at some other problems that I think they're less interesting. They're not included here. And several of them are related to the last two example problem. I think so these two, this maximum number of events can be attended and maximum number of error. So these two are also this interval based. So I highly recommend you take a look at those. And the last two are somewhat challenging. It's okay that if you read solution and still find it difficult to understand. There's this is higher. This is above the level of we expect in CP1. The earlier one are a little bit easier, but they are still, I think, starting from here, it gets starting from jump game 2, it gets interesting. The first two are fairly straightforward. Okay, so that's it.